All right, so let's do an example with cosine. Y equals -2 cos 3x minus 2 pi plus 1. All right, I'm going to put down our formula again just because I find it comforting to have it easy at my access. Y equals a trig b x minus h plus k. Okay, well, first thing I notice is that my b is in the wrong position. I need to factor this 3 out. So I'm going to get y equals -2 times the cos of 3 times x minus 2 pi over 3 plus 1. Okay, so now I'm in the position I like. Let's figure out our dilations first. Amplitude, the easiest one to figure out, is at -2. That means our graph is going to, if I start at, oh, we're doing cosine, so natural to draw sine. So cosine, the -2 tells me that I have to flip it over the x-axis starting down here rather than up here. And I'm going to stretch it by 2 units. So instead of being at 1, I'm going to double that to 2. So I'm at -2. Same thing here. My -1 is now going to flip and be at +2. And then my pi over 2 value, excuse me, my +1 value at x equals pi over 2 is going to drop down here and be in line with my other point at -2. So now if I sketch that in, I'm going to get this shape. Okay, so that's only one dilation. That's the effect of amplitude. Now I want to look at the effect of the period. So period is 2 pi divided by absolute b. So this is 2 pi divided by 3. No simplifying that. This means, without taking the amplitude into consideration, that the cosine function now, instead of finishing in 2 pi units, it's actually going to complete in pi over 3 units. 2 pi over 3 units, excuse me. And 2 pi over 3 is just past 90 degrees. So now the whole thing, not making the dilation on A, the whole thing completes there. So it's going to be really squished up and it's going to stretch out as well. So let's go ahead and make that sketch so we have a parent to work with and see where we are. So I'm at -2 and +2. And it's not easy. If I say that this is 2 pi units and then say that this is 2 pi over 3 and try to draw this in here, that's crazy. Whenever you're working with a trig function, what you really want to do is sketch the graph and then label it to fit your needs. So because I could say that this is a 1, 2, 3, 4, 5, 6 interval graph, or I could say that it's a 1, 2 interval graph. I have that freedom, so let's use it when we need it. So if I just sketch in a cosine function and I label the endpoint as 2 pi, whoa, let's not do that. That's the standard position. If I sketch in the inverted function, so I've put into consideration what happens with the stretch on A, and I've squeezed it by labeling 2 pi over 3 units. Now I need some critical values, right? Some of them are easy. This one is at x equals 0, y equals -2. And this one is at x equals 2 pi over 3, y equals -2. This one up here is at, You gotta love digital ink. This one, I know that my y-ordinate is 2, but what is my x-ordinate? Where is that? Well, notice that this is right in the middle of my graph. And so what point falls right in the middle of 2 pi over 3? If you're not sure, do a little scratch work. 2 pi over 3 divided by 2 is 2 pi over 3 times 2. 2's cancel, so that is pi over 3. Pi over 3. Oops, pi over 3. Now, I get it. If this is 2 pi over 3, halfway is 1 pi over 3. I just like to reiterate that it's super simple to do the arithmetic on it. Don't get yourself bogged down with complicated thoughts when you can just sketch it out really quick in pencil and pen or pencil and paper. All right, let's move on. So what I need to know is, where are these points? Well, it turns out that sine and cosine curves are very symmetrical. So if this is halfway at pi over 3, then each of these are halfway between the end point and the center point. So halfway from 0 to pi over 3 is pi over 3 divided by 2, which is pi over 6. Easy peasy. So that's this point, pi over 6. I'm not going to write it because it's getting messy in there. And then this point, oh, I guess I could write just pi over 6 here. And so where am I here? Well, pi over 6, or pi over 3, halfway between the two. 2 pi over 3 plus pi over 3, and divided by 2. So 3 pi over 3 divided by 2. 3's cancel, I get pi over 2. And so this point here is at pi over 2. So I'm halfway there. I've done the dilations. And I get critical points I'm going to work with. I have y equals the dilated equation, negative 2 cos 3x. So that's with all the dilations intact. Now I have to put in my phase shift and my y up-down shift. So the points that I want to work with, and I'm not going to do these points, you'll see why in a minute, but I'm going to work with the end points and the vertex points. So I have 0, negative 2 is one of them, pi over 3 and 2, and 2 pi over 3, negative 2. So let's start with our translation on our x ordinates, meaning just the forward action on our x ordinates. And that means I'm going to move everything forward 2 pi over 3 units. So x plus 2 pi over 3. So 0 plus 2 pi over 3, 2 pi over 3, negative 2. Pi over 3 plus 2 pi over 3, 3 pi over 3, pi 2. And 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. And negative 2. So I've moved all of these points now forward 2 pi over 3 units. And now what I want to do is move them up 1 unit by only changing the y ordinates. So y plus 1. Well, I already know my x ordinate, 2 pi over 3. Negative 2 plus 1, negative 1. Pi, 2 plus 1 is 3. 4 pi over 3. Negative 2 plus 1, I'm back at negative 1. So let's put this in the graph. I know that the center of my graph is going to be the line y equals 1, right? Because what used to divide the graph horizontally into two sections was the x-axis, but now the whole graph is going to move up, so that means that the x-axis, or the dividing line, will move up to y equals 1. And our first point on the graph is at 2 pi over 3. So if I just sketch in the curve, I can label this point at 2 pi over 3 and negative 1. So if this is negative 1 and this is 1, that means my x-axis is here. And if this is 2 pi over 3, that means my y-axis is back here. So I know where 0 is, and I've identified the location of the graph. Now, if I wanted to keep going, I'd have to find critical values for those, or high and low points, or maybe I would want to find the x-intercepts. In this case, I'm not going to look for them, but it might be something to do. Next, I want to find out what happens to the high point. How did it end up? Where did it end up? Well, it ended up at pi and 3. So this is pi. I've got pi and 3. So that would make this 3. And then my last point, 4 pi over 3 and negative 1. Now, I do happen to know what these points are. They would be pi over 6 forward, 2 pi over 3, and up 1. And those are calculations I can do pretty quickly in my head. I get 5 pi over 3. Is that correct? Pi over 6, 2 pi, 4, 5 pi over 6. Thank you for catching that. And 1. And then for this point, pi over 2 to go forward 2 pi over 3 units. Common denominator, quick work in your head. 7 pi over 6. You know how good I am at arithmetic in my head, but I think that's right. And so now I have graphed this graph. But let me recap real quickly. I think the easiest way, even though this is a lot of work, the easiest way to graph translated trig functions is to first find the graph and the parent function for the dilations, and then to use the point translation method on whichever points you want. I went ahead and did these points. They're not really necessary usually when you're graphing. As I said, sometimes it's critical to find the x-intercepts, and that's another calculation. But generally, if you have starting point and high points and low points, you're good to go.